Alright, here with Newton's law of cooling, what you've got to do is first we've got to pay attention to, here's our formula. T is whatever the temperature of the object is. C is the constant, that's the room temperature. T sub 0 is whenever we take it out of whatever we have, like in this case the oven. And then E is just E. We're trying to find K. And then the lowercase t is the time in minutes. So the first thing we've got to do is we've got to find K, so then we can plug it in. So we've kind of got to do a little bit of pre-work for everything. So whenever we have this, we have T sub 0, which is the 222 degrees. We have the constant temperature, which is 74 degrees. We have the total, or the temperature at whenever we took it, that was after 20 minutes. So all this information is relevant, so then we can find K first. So what I want to do is I want to take 148 equals 74 plus 222 minus 74 times e to the negative k times 20 power. We're going to solve from there, so I'm going to condense. I'm going to have 148 equals 74 plus 148 times e to the negative 20k. Subtract 74. So whenever I subtract 74, I end up with 74 equals 148 times e to the negative 20k. Divide by 148. And I get 1/2. So 1/2 equals e to the negative 20k power. Since it's e, I'm going to have to use the natural log of 1/2, or 0.5, whatever you want to call it, is equal to negative 20k. Now I'm going to divide by negative 20. So my K value is whatever the natural log of 1/2 or 0.5, whatever you want to call it, divided by negative 20. So what I'm going to do here, I'm going to go to my calculator. I'm just going to type that in. So whenever I do, so I'm going to clear off out of that. So if you need it, pause it, and then I'll go to my calculator. I'm going to take the natural log of, I'm just going to put it as 0.5 because it's 1/2, divided by negative 20, and I'm going to get a K value of 0.034657. I'm just going to go out to 4 decimal places. So whenever I do that, my K value is going wrong thing. My K value is going to be equal to, my K value is going to be equal to 0.0347. Now what's going to happen with that, I'm going to plug this back into my formula. So I'm going to plug this back into my formula, kind of that I had somewhere here in the middle where it was so that way I'm just going to call this T equals my constant, which is 74, plus I'm going to have my 148 times e to the negative 0.0347 0.0347T. Now that I know that I want to find it after 35 minutes, so now I'm just going to plug it in. So instead of a T up in my power, I'm going to have 74 plus 148 times e to the negative 0.0347 times my 35. Now, depending on what kind of calculator you have, you can kind of do a little bit more for everything. What should happen is we should end up with like T equals 117.93 degrees. Now it says in here to round to the nearest whole number as needed. So I'm going to say it's about 118 degrees is what should work. Now whenever I do this, again, I'm going to go to my calculator. I can do the exponent first, and I'm going to show you just to make sure that you know kind of how to input it. So if I take my negative 0.0347 and I multiply it by 35, so I'm going to get this decimal. Okay, I'm going to take it and I need to take it to the e power. So I'm going to hit second in the natural log, so I have e to a certain power. And I'm going to either, like in this case, I can just type in negative 1.2145 and go from there. Or I can just have e, and I can hit second and then the negative symbol, and it's going to give me whatever my last answer was. Hit enter. I'm going to multiply that by my 148, and I'm just going to leave it as I go. I'm going to have 43.93. I'm not going to round it until the very end. I'm going to add my 74 degrees, and I'm going to get 117.935, so on. Again, it says round to the nearest decimal place, or round to the nearest degree, so I'm going to round to 118 degrees.